Welcome back to geometry. We're ready for 12.2, which is on chords and arcs. We've actually already talked about arcs. Arc length is a fraction of the circumference, right? We did that back in previous chapters. Now we're going to also talk about chords, though. A chord is a line segment with both endpoints on the circle. Here's what I mean. So you have a circle. Draw any line segment where both endpoints are on the circle. That would be a chord. That would be a chord. That's a chord. That's a chord. So there's an infinite number of them. Now you might think about a diameter. So a diameter is the longest chord, right? And the way you can tell it's a diameter is because it goes through the center. If I put a dot there, that's indicating that's the center. So a chord is a line segment with both endpoints on the circle. An arc is, again, this distance around the circle, like that length, that length. Now you can have arc length. You can also have arc measure, which might be, we talked about that as well. So an arc length, we might say, call this AB, the length of the arc AB, maybe if that's a distance 3 centimeters, then we'd say equals 3 centimeters. But if that, we often will also see something like this and say this is 30 degrees. And what they're saying is that's 30 degrees. So the arc measure, call this C and D, the arc measure always equals the measure of the intercepted angle that opens up to it. So that's the distinction. So those are arcs and chords. So there's a number of big ideas in this section, so I'm going to try to introduce them in a way that's a little more memorable than the book does. The book just lays out a bunch of theorems. Let's see how many. 1, 2, 3, 4, 5, 6, 7 theorems. So I'm going to try to show it to you in 2 big ideas. And we're going to try to figure this out in kind of a demonstration. So let's draw a circle. Okay, and let's say we have a chord here and a chord here. And let's say they're congruent to each other. So this is the idea of congruent chords. What is true? And this is an example I occasionally like to give is imagine you're cooking and you, let's imagine you're a spoon, okay, and someone is cooking with you. So here's the hot pot from above, okay, there's the handle, and you are dropped in there. You don't want to drop your spoon in there, but accidentally you've been dropped in, okay, and you're laying here like this. And for some reason, we're going to assume this pot is hottest in the middle, okay, and as it goes out, it gets a little more manageable. So where would you want to go? You'd want to go to an edge, right? So you might scurry off to this location right here. Okay, so I might ask you, where should you go to get as far from the center as possible if you're a spoon falling in a pot? Should you go there? Should you go over here? Should you go over here? Should you go over here? Hopefully you know it doesn't matter. They're all the same. I mean, you could turn this circle. There's symmetry in a circle. It does not matter. So what we've discovered is this. Let's go back to this original figure. We'll draw one more maybe here. Say these are all the same length. We've discovered that these are all the distance to the center So if you want to do distance from a point, the center, to a line, you must measure that perpendicularly, right? So if you want to say how far am I from a tree, you'd want to measure straight to the tree, not from you to the top of the tree or something, probably straight along the ground. So in this case, we're saying these are all the same too. So that's our first big idea. Congruent chords are equidistant to the center. And I don't want to do a lot of writing here, if I can avoid it, congruent chords are equidistant to the center of the circle. And hopefully that's pretty intuitive, right? I mean, it doesn't matter where you go, you'll be equidistant. Now, how about this? Back to our example, let's say there's some peas in the pot, okay? I'm going to do some erasing up here. Let's say there's some peas in our pot. Oops. We'll just start over here. So you got some peas, right? Some nice green peas, tasty peas. Okay, would you be able to, if you want to squish them against the center, okay, with your spoon here, should you squish them against the left side or the right side or maybe on the bottom? If the spoon's the same length, it doesn't matter, right? If the spoon is the same length, that the room for peas is the same. So the area, which actually we're not going to talk area, but that area, if I drew this well, would be the same as that, be the same as that. That's helpful, but we're not really going area here. What we want to get to is the next step is that this arc length. That arc length, this arc length, and this arc length would have to be the same. Okay, so what I like to say, here's my phrase for this one. So phrase 1. Phrase 2 is congruent chords cover congruent arcs. Now I'm saying the word cover, I think the book says like intercepted, but I like to think of it as being covered, okay? Imagine you are this spoon here and you're covering the chord out here. I'm sorry, the arc. So congruent chords cover congruent arcs. Okay, and guess what else? We've kind of already talked about this, but if you have arcs that are congruent, so in other words, this arc here is the same as this one, is the same as this one. So it's kind of a domino effect of ideas. If chords are congruent, or if chords are equidistant to the center, they're congruent. If they're congruent, they cover congruent arcs. If they cover congruent arcs, well, remember we talked about the, congruent arcs? We said that their measure is equal to the central angle. So what do you think about that angle compared to this angle? Yeah, they're congruent. And this one too. So congruent chords also cover congruent arcs, and congruent arcs open up to congruent central angles. And you can see why there's so many ideas. I'm gonna condense them here in a moment. So we'll say congruent arcs open to congruent central angles. So open, again, is kind of informal language. So here is the way we could cover these ideas here. You see things like congruent central angles, congruent chords, equidistant to the center, and congruent arcs is on there twice. Let's get rid of that, okay. So 4 underlined things. Those are the 4 ideas, and they all fit together. So here's how I often think of this is you have this triangle, and in the triangle there's 3 congruent statements. This is kind of a visual. We have congruent arcs, we have congruent central angles, and we have congruent chords. And if you have one of them, you have all 3. If your arcs are congruent, then those chords they kind of cover are congruent. If your arcs are congruent, the central angle they open up to are congruent. If the central angle is congruent, then it opens up to congruent chords. They're all the same. And then the one other one, and for whatever reason I find this helpful to put in a different spot, because it's not a congruent statement, but we'd say chords are equidistant to the center. Okay, so the triangle has all the congruent statements, and then since chords was on the bottom, it ties in congruent chords or equidistant to the center. So those four things tie in together, and hopefully that helps make sense. I'm going to stop it here and